The first question asks me to, and I'm going to use my camera so I can actually write this out and you can see. But remember, when a question asks me to convert a fraction, a decimal into a fraction, remember my rules for converting. So 0.15, remember my rules for converting are going to be as follows. I'm going to, I don't know why that's not becoming clear. There we go. I'm going to make a fraction bar. I'm going to put whatever I see after the decimal on top of my fraction, and then remember to count how many digits there are. There's 2 digits, and that's how many zeros I'm going to add after 1. So my answer is 15 over 100. Now notice that it says, do not try to simplify your answer. So on my Alex screen, I'm just literally going to type in 15 over 100. Marks it right. I'm not sure why it asked me not to simplify, but on Alex, it's asking me not to. Okay. Remember that if there's a repeating bar over your decimal, that the rules kind of change just a little bit. So instead of, here's my problem. Remember, this is the same thing as 0.67676767, and that 67 just continues to repeat forever. So what I'm going to do is I'm going to take those 2 digits like I did on the last problem, and I'm going to stick them on top of my fraction. But instead of counting the digits and writing a fraction bar and writing 100, I'm going to make an adjustment. I'm going to think 100, okay, but since it's repeating and it doesn't stop, 100 is for terminating. Repeating, I'm going to subtract 1 from that amount. So instead, I'm going to write 99. Or some people think about it as there's 2 digits, so there's 2 nines. So just to give you another example, so what if I had 0.123 repeating? Then I would have 1, 2, 3 on the top of my fraction, and since there's 1, 2, 3 digits, I'm either going to write 999, or I can think about it as 1000 has 3 zeros, minus 1 is 999. So that is my repeating rule. So remember, it is different than if my decimal terminates and it stops. Question number 3, we're just gonna kind of go through a couple of those. So if I'm writing this one as a fraction, I'm gonna do the same thing. I'm going to write now, but I'm not gonna bother to write all of the zeros. Okay, but I'm going to write 9, but I am going to count zeros as part of my digit. So 1, 2, 3, 4. So I'm going to have 9 over, see that? 9 over and 4 zeros. 1, 2, 3, 4. Okay, so remember, it is important to use all of those underneath there. So that's kind of my decimal work. Okay, this next section asks me to classify things as rational numbers or irrational numbers. Now, if you have forgotten or you were never quite sure how to tell the difference or which one to click, remember that the difference between rational and irrational, okay, irrational, it cannot be written as a fraction. Can't be written as a fraction. Rational, okay, can be written as a fraction. Any of you word people that like the English type of stuff, hey, you'll notice that rational is part of both of those words. When you add like irritable or like irrelevant to the front of any word, hey, it makes it like not. So relevant means like applicable. Irrelevant mean like inapplicable. So rational can be a fraction. Irrational can't be a fraction. So any word people, I find that interesting. So as I'm going through my list and trying to mark rational or irrational, I've got to think of all the different kinds of numbers that can be written as a fraction. So obviously anything that is a fraction, like 16 over 9, is rational. Okay. Anything that has a pi, a digit of pi in it, is irrational. And we've talked, I think you've probably learned the last couple of years, whenever you've talked about pi is 3.141592, and it continues on forever and it doesn't stop. Okay, so that's what we would call irrational. Okay, can't be written as a fraction. It doesn't repeat either. Okay, pi does not repeat. Okay, so it can't be written as a fraction. Now, as I'm going through the rest of my options, my maybe not so obvious ones, we're going to do a little bit of testing. Okay, if I have something that has a repeating decimal, okay, remember we just talked about how to convert repeating decimals into whole numbers. Into fractions. So can I turn negative 35.56 repeating into a fraction? Well, I can turn it into negative 35 and a mixed number, 56 over 99. So can I turn it into a fraction? Yes. And I'm going to click the rational option. Okay. 6 square roots of 2. Anything with a square root, that is not a perfect square. So if I type it into my calculator, let me show you. Let me type it into my calculator. If I type it into my calculator and I get 2 square roots of 6, and I type it in and I get this big long decimal. Okay, notice that it kind of starts to repeat 8989, and then it says 798486. If this is not a whole number, or if this doesn't stop after like 3 or 4 decimal points, okay, I know that this is not a rational. I can't write it as a fraction since it's not repeating and it doesn't stop. I'm going to mark that as irrational. Now the last one, that square root of 1, sometimes people make the mistake of thinking, hey, all square roots are irrational. A lot of the times that's the ones that you are going to see that are irrational. But always be sure to test them, because if I type in square root of 1, you'll notice I get an answer of a whole number of 1. Okay. All whole numbers are rational. They can be written as a fraction. 1 can be written as 1 over 1. So I would put that in the rational category and we'd be done. Any questions on that? So as you're sorting through, choose the obvious one first. Hey, anything that has repeating, I'm going to put in the rational category. Anything that's a whole number, I'm going to put in the rational category. Anything with a square root, I'm going to be wary of. I'm going to type it into my calculator, and if it doesn't give me a whole number, I'm going to mark it in the irrational category. All right. So clicking on to our next section. So our next section is going to move away from rational and irrational and converting things into fractions, and it's going to talk about simplifying square roots. Now remember, if I have a perfect square, meaning a square root that gives me a whole number, it's okay to type that into my calculator and simplify. So for example, it says square root of 25. So I'm going to very first time, anytime I see a problem that says, what's the value? I'm going to just type into my calculator. The square root of 25 is 5, and I can check my answer. Try another. Square root of 9, that's also a perfect square. So square root of 9 should also give me a whole number. It's 3. It says find all of the real roots, all of the real square roots of a number. Okay. If my number is positive, okay, so for example, if I have positive 4 instead of negative 4, I'm going to click on this explanation because I think this will do a better job of explaining. Okay. If I'm trying to find all square roots of negative 4, you'll notice if I try to type it into my calculator, square root of negative 4 is impossible. It says, all right, can't compute. I'll say error. Okay. The reason why is I can't think of a number that multiplies by itself to give me negative 4. If I look at kind of these options, so for example, if I take a positive 2 times positive 2 is a positive 4, and negative 2 times negative 2 is also a positive 4, there's no way to end up with a negative. So if I went back to this question and I had to answer it, I would want to say none. Now, on the other hand, if I had this question where it says find all the real square roots of 64, now 64 is not a negative number, so we're not going to click none. We're going to think of one number that I can multiply by itself to give me 64, or you can type it into your handy dandy calculator. square root of 64, and it'll help us out maybe with the mental load. So 8 is one of my answers. 8 times 8 is 64, but don't forget about that opposite. Negative 8 times negative 8 is also 64. So I want to make sure I click both of those answers. There are some problems that are going to ask you to approximate. So this one is one that I'm going to type into my calculator. So square root of 56, and it said round to the nearest hundredth. Make sure you feel comfortable with how many decimal places a hundredth is. The way I remember it is 100 has 2 zeros, so hundredth means I'm going to go 2 decimal places after. So if I type it into my calculator, I get 7.4833. So I'm going to cut it off after the 8, but don't forget to double check to make sure you don't want to round that 8 up to a 9. But since I see a 3 after it, I'm good to leave it as 7.48. All right, number 8. Number 8 asks us to order the numbers from least to greatest. So before I even start the question and trying to decide, pay attention to what's positive and what's negative. If there's only one positive number, that's automatically the greatest. So 8.2 is automatically, 8.02 is already the greatest. Any negatives are automatically the smallest. And if I have a couple of positives or a couple negatives, then I have to decide between the two. So in this problem, 8.02 is the biggest no matter what. Now we're just trying to decide between these 3 negative numbers. Okay, which one's the smallest? Remember that in order to compare, looking at them in the same form is going to help me do that. I can most easily turn a fraction and a square root into a decimal, so I'm going to go ahead and do that. So if I wanted to turn negative 73 over 9 into a decimal, I type into my calculator negative 73 divided by 9, and that gives me negative 8.1. So negative 8.1 repeating. Then I have the negative 8.3 repeating that I need to compare it to, and negative square root of 65 turns into negative 8.062, and it continues. So if I'm comparing these 2 numbers, which one is the smallest? Okay, remember that we're looking at negatives, so we're looking at it to be the most negative. So when comparing these 3, when I look at decimals, I kind of like to think about it as money or how many cents. It says repeating 1 would be like having 11 cents, repeating 3 would be like having 33 cents, and having 0.06 would be like having 6 cents. So the larger the negative, the smaller it is. So 33 cents is more than 11 cents. So that negative 0.33 repeating is my smallest. Negative 0.11 would be my next smallest. So that was my fraction, and negative square roots of 65. And I can check it, and we're good. Question number 9 asks me to simplify a radical. So as a reminder, how to simplify, remember on question number, I believe it was number 5, number 5 and number 6, I could just type into my calculator. But if it's not something that's a perfect square, or if it's not saying something that says, hey, approximate, I'm going to use my factoring process where I see what common factors go into 75. 75 can be split into 3 and 25. And 25 can be split into 5 and 5. Now, if you're not confident about what goes into 75, just start dividing. 75 is not even, so I wouldn't pick a 2, but I would pick a 3, and there I go, 3 and 25. Excuse me. I'm going to rewrite my radical. It is a combination of those factors, so 3, 5, and 5. I circle my pair, and it comes out, so I have a 5 on the outside and a 3 left on the inside. So 5, radical 3. And we have and it says simplify square root of 20. Notice it doesn't say tell me the value, because if I type in square root of 20 into my calculator, I get a big long decimal. Okay. Square root of 20 gives me this big long decimal. Okay. And if that's not a whole number, I can't write it in that spot. So remember, and I jumped all the way to 10, but this is also something I want to review. If I want to simplify square root of 20, remember, here's my steps. Okay, to simplify a square root, I'm trying to simplify it into its factors. 20 splits into 2 and 10. And I can kind of scribble out 20 because I'm not going to use it again. 10 simplifies to 2 and 5. Okay, and I scribble it out because I'm not going to use the 10 again. 2, 2, and 5 all multiply to give me 20. Okay, but they are as simple as I can. So I would write 2 times 2 times 5 in place of square root of 20. And then what I do to simplify is, remember, I flip for those perfect pairs, because that is something I can take the square root of. The square root of 2 times 2 is, okay, whatever that pair is. So square root of 2 times 2 is 2. And I can scribble out the inside, and I'm left with 2 square roots of 5. Make sure you use your little tool, 2 square roots of 5. Okay, so make sure you realize for question number 5, I can just type it straight into my calculator. But as soon as I get to questions like number 10, or maybe number 11, I've got to use my factoring method. Square root of 150. Boy, big number, but we're just going to do a little bit at a time. 150 splits into 2 and 75. 75 splits into 3 and 25. 25 splits into 5 and 5. Now, if you recognize something else that it splits into other than 2 and 75, okay, stick with that. But I'm going to take my square root sign and I'm going to cross out anything that I split because I don't want to reuse it. I have a 2, a 3, a 5, and a 5. And I circle any pairs and those come out. So 5 comes out. Those 5s cancel out. So I'm left with 5 square roots of, and instead of leaving 2 times 3, I multiply them back together. So 5 square roots of 2. So 5 square roots of, sorry, I said 2, and I meant to say 6. All right, a variable, because I realized when I had a student ask me about odd exponents of variables, that I didn't go over an example of that. So remember, when I have a variable and I have a whole number, I'm going to treat those differently. So just like I did on the last couple of problems where I had to simplify a square root, I see what goes into 54. Now, 54 is one of those odd ones we don't see. It is a multiple of one times table that we do know, but it's not a super common. So if you are in doubt, just start dividing it by numbers. So I'm going to start with a 2. So I'm going to split 54 into 2 and 27. 27 splits into 3 and 9. 9 splits into 3 and 3. We cross out everything, we split, and write it. So 2, 3, 3, 3. Circle my pair and pull it out. And anything left on the inside gets multiplied back together. So I have 3 square roots and 6. Now let's take care of the w's. Remember w to the 7th power, and we're going to keep talking about exponents in our next section. So w to the 7th power is w, 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 w. And you can imagine I'm going to write it, yes, 7 times. 1, 2, 3, 4, 5, 6, 7. There is a shortcut of, if you recognize I'm just pairing these together, I can divide 7 by 2, which is 3.5, and it'll tell me how many w's to pull out. 3, I'm going to pull out 3.5 stays behind, but this way will always work. So circling my pairs, I'm going to pull 3 w's out front, w, 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 but instead of writing w, 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 remember, I'm going to write w to the 3rd power, and I'm going to leave the other w on the inside. So 6 stays on the inside. The remaining w stays on the inside. The w ends up on the outside as w to the 3rd, and the 3 comes in front. So that would be my final answer on question number 12. Answer. Number 13. Here's another chance at simplifying a radical with a square root. So this problem says square root of 54, y square roots of 10. So we have another one of those radicals of 54. So we're going to do the same thing as we did before. What goes into 54? And if you're not confident, I like to start by dividing by 2 since it's even. So 54 divided by 2 is 27. So 2 and 27 turns into 3 and 9. And 9 turns into 3 and 3. Remember, we deal with our radical and our number and our variable separately. So 2, 27 is split, 9 is split. So 2, 3, 3, and 3. I have a pair of 3s that can come out, and a 2 and a 3 left on the inside. So 3's on the outside. So I could bring out a 3. So 3's on the inside. The 2 and the 3 are left on the inside. So 2 times 3, I could put them back together, is 6. Now let's deal with the 10. Y to the 10th power. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if I find all of the pairs, I have 1, 2, 3, 4, 5. And I can kind of shorten that process by thinking to myself, maybe, if I have 10 Ys, that means I have 5 pairs. So 5 pairs means I have Y to the 5th power on the outside. And I circled all the Ys, so there's nothing remaining. And this is my answer. Yes. Okay, so similar question. I'm going to move on to hopefully a review of the adding and subtracting. So remember, with adding and subtracting, the insides have to be the same. So it's kind of like combining like terms. If I had 3x minus x, I would want to combine the numbers in front. So 3 minus, there's an imaginary 1 right here. 3 minus 1 is 2. And don't forget that I'm not going to simplify that. I'm not going to do anything with the inside other than bring it along for the right. We're going to see how far we can get. So remember, if the square roots are not the same, remember I'm going to simplify both of the square root signs. And then I'm going to see then if I can combine them. So for example, on this particular problem, negative square root of 98 minus 4 square roots of 32. I'm gonna split 98. And again, 98 is one of those that I'm like, I know it should be divisible by something, but I'm not sure exactly what, but I know it's even, so I should be able to divide it by 2. So I'm gonna divide it by 2. 98 splits into 2 and 49. And I'm super happy to see the 49 because 49 splits into 7 and 7. And I can stop there. So I have negative square roots of 2, 7, and 7. I pull out my 7 with that negative, so I have negative 7 square root of 2. Okay, and that's that entire first section. Now I'm going to simplify this entire second section. So 32 splits into 2 and 16. 16 splits into 4 and 4. Now I'm actually going to stop right here. I noticed that I have a 4 and a 4. One shortcut that you can use instead of simplifying all the way down is if I notice that when I split a number, I end up with 2 of the same. Instead of continuing, I'm actually going to stop and I'm going to do this. I have this 2 from up here, but this 4 and this 4 are going to be their own little pair. There's nothing else, or there's nothing else that I need to worry about, so it's allowed. So I'm going to pull a 4 out to join this other 4 that's already out there. Remember, I multiply those together. 4 times negative 4 is negative 16. Square root of, and you'll notice I have a little 2 on the inside. So I'm going to rewrite what I have, and you'll notice that the insides of my square roots are the same. They're matching. So I'm going to bring down that square root of 2, and I'm going to combine what's in front. So negative 7, and I don't want to do this wrong. It's been a long day. So negative 7 minus 16 is negative 23. Okay. So negative 23 square root of 2. Number 16. This problem asks us to do a multiplication problem with my radicals. So the square root of 27 times the square root of 3. Now with multiplication, with addition I couldn't combine them unless they were the same on the inside. With multiplication I can. that is allowed. That is the same thing as saying 27 times 3. So what I'm going to do is I'm not going to necessarily, I can just multiply them together, but remember we're going to end up factoring them down again. So I'm actually going to just leave it as square root of 27 times 3 and split that square root of 27 into my factors. 9 and 3, 27 splits into 9 and 3, 9 splits into 3 and 3, and notice then I have a 3, 3, 3, and a 3 left over. So 1, 2, 3, 4 3s. I circle my pairs and those come out. With 2 3s on the outside, I multiply my exterior. So my exterior is 9, and I notice in this case, my inside goes away. So I no longer have to write my radical sign, and my answer is just square. It's not a square root at all. It's just 9. Now, sometimes I am going to be left with something left on the inside, but not always. Let's look at this for example. If I have 4 square roots of 50 times square root of 18, remember that that is the same as saying 4 square roots of 50 times 18 on the inside of my square root. And we can separate those, that 50 and that 18, all underneath the same square root. So 50 can split into 25 and 2. 25 splits into 5 and 5. Cross out what I've combined. 18 splits into 9 and 2. 18's gone. 9 splits into 3 and 3. 9's gone. So I've got one big square root sign with all of these factors underneath. 5, 5. I've got a 2 and a 2. I've got a 3 and a 3. And I've got a 4 on the outside. Well, looks like I might have the same thing where I don't have anything left on the inside. I've got a pair of 5s that's going to come out. A pair of 2s that's going to come out. And a pair of 3s. With nothing, in this case, nothing left on the inside. So a pair of 3s, a pair of 2s, a pair of 5s, and a pair of 4s. So on the outside, I have 3 times 2 times 5 times 4 for a grand total of 120. Okay, and no square, no more radical. Okay, number 18, and I was just checking this out before we started. Number 18 asks me to simplify this square root radical. It's got like this division in it. But instead of talking about division and dividing and trying to divide my square roots, what we're going to do is same idea as the multiplication. I can rewrite it as one big square root of 54 over 6. And this works only for multiplication and division, that I can combine them inside the same square root. Before I do anything else, I could find some common factors, or if you notice, if this is a common times table 50 or a common division, 54 divided by 6 is 9. So inside my square root simplifies to a 9. Now, before I go any further, I recognize that 9 is a perfect square, so the square root of 9 is just 3. And you can type that in your calculator to be sure if you're not 100%. Number 19 asks me to look at a cubed root. Notice that it is a cubed root because it has a little 3 right here. Meaning that instead of just having two numbers that multiply together, so like a square root where I had 3 times 3 was 9, so the square root of 9 was 3. A cubed root says I multiply the same number 3 times together to give me an 8. So, or in this case, a negative 8. So I could probably come up with that myself. 8, and I can do that factor tree. So I'm going to split this out. 8 can be split into 4 and 2, and 4 can be split into 2 and 2. Since this is a negative, that means they all have to be negative. A negative times a negative is a positive, times a negative is another negative. So my answer on this one is negative 2. Also, if you go into our decimals calculator, our class decimals calculator, you can find that cubed root button and just type it straight into your calculator. That's also another option. Okay, and last question, simplify. It says 27 is equal to W to the third power. So this is essentially asking me kind of the same thing. If 27 is equal to W, I'll show it so you can see it, W to the third power, I'm trying to think W times W times W, what times what gives me 27. So we can do a cubed root. Okay, the opposite of cube is a cubed root, or I can kind of reason what times what is 27. And you can factor 27. 27 splits into 9 and 3, and 9 splits into 3, 3, and 3. So if 27 splits into 3 times 3 times 3, that means my W is equal to 3. So W is equal to 3. And if it had been a negative 27, my answer would have been a negative 3. All right, and that's it. Good luck on your test. If you have any other questions, please feel free to reach out. Bye.